So this is our presentation. We did it on car accidents and the population in Florida. So we had two different data sets.
So for a little bit of background, Florida is a state that gets a lot of snowbirds coming down every year. So the population changes drastically depending on the month or time of year that it is. And our goal in this project was to figure out if the rates of people coming down to Florida affect the rates of car accidents.
So our hypothesis for our project was that the increase in population each year would directly impact the number and severity of car crashes that occurred. So more specifically, like the time that snowbirds are down in Florida, there would be more car accidents occurring. And this makes sense because there's more people on the road when snowbirds come down here, and then that would bring more cars onto the road, and then more accidents occur.
So our first data set shows just the population. It's from macrotrends.net. So here you can see that the population has increased significantly over the past few years, but especially in the later 2000s, it's been increasing more and more.
Our second data set was of the car accidents in Florida. It was found on the Florida Department of Transportation. The data that was provided was for car accidents that occurred in each month from the years of 2017 to early 2021. The car accidents themselves were separated into three different types. Crashes were just general fender benders and just like, issues with your car. Serious injuries is just like ones that are obviously survivable but way worse, or like totaling your car. And then the last one was fatalities, and that's self-explanatory.
So we managed our data by filtering out the different crash types, because since the crashes were separated by severity, obviously there's going to be a lot more crashes that are just considered crashes or not serious or fatal. So that one was so highly elevated that on the same map, on the same graph, it's hard to see the disparity between the things. But we also separated by different months to account for snowbird season. So the months of October to November, around to about May, were separated from the summer months where there's less snowbirds here. And then we also filtered the years, because one of our data sets was from 2010 to 2023, and then the other one was from 2020 to 2023.
We also had to combine the years because there were two different columns of year and month, so it made the data stacked when we graphed it. So we had to mutate the data a little bit to do like the year plus the month, so it'd be like 2020.1 for January of 2020 in order to correctly graph it.
So this is our first figure. As you can see, it's pretty scattered throughout, but you can tell the lower end of the crashes in 2020, where we have COVID happen, so less snowbirds came down, is a lot less than in 2019 when we were at our peak season and crashes were higher.
So our second figure was the total accidents in January and July for all the years. As you can tell, the crashes are so much higher, so you can't really tell the difference in the fatalities or serious injuries. But this is to like kind of show all three categories in the 2 months.
Here's where we separated them. So this one right here is just looking at the general crashes. And you can see that in January we had a lot more crashes than there were in July. Even the minimum number of crashes in January were still higher than the highest number of crashes in July.
So this is the figure for the number of fatalities, and compared to the one with all three types of accidents, you can actually clearly see the amount of accidents occurring in January and July, and that January is still much higher for an amount.
Here, there is less of a disparity between the months, but you can still tell that overall, the max number of crashes or the max number of serious injuries in July was still greater than the max number of serious injuries in January.
So this is the table that we had to kind of hand manipulate. We had to add up every single accident that occurred, which includes the crashes, fatalities, and serious injuries. We did it for each year, and we just added, had to do like the sum of all the numbers, and that's what it looks like. And then this is what it looks like on a graph, and you can clearly tell that in 2020 there's a huge drop off, which could be expected due to COVID issues and no one being on the road.
Here we have a graph of our population from 2010 to 2023. As you can see, it's increasing every year at a pretty fast rate. Here we have a table for our population growth rates for 2020 to 2023. You have our population here and then our growth rate over here measured in percentages between the differences between each year. This one shows the population each year between 2017 and 2020. It goes up pretty significantly until 2019, where it hits a bit of a plateau and it stays relatively the same until early 2020.
So this is comparing the two graphs of the number of accidents compared to the year, and then the population compared to the year. So looking at it, you can clearly tell that as the year continues, the number of accidents decrease, but as the year continues, the population actually increases. So that kind of goes opposite from one another. Then to show this, we did correlation tests, and this is just showing that there's a negative correlation. So that's like a strong negative correlation between the two, which is not what we were expecting. And then we thought maybe the year 2020 would affect it, and it actually made it stronger. So the one on the right is the one that is excluding the year 2020. You can see the correlation value is much higher.
So for our results, basically we found that the population, as you can see from the last graphs, were inversely related to the crashes. So our hypothesis is a little bit incorrect, but if we go further into the graphs, we'll see a little bit more.
So diving a little deeper, our original hypothesis based off of the yearly population growth and changes was very much incorrect. The number of accidents compared to the month was accurate, and that's comparing the January and July months and showing that January with more people here is higher.
So for further research, I think it would be more representative of our data if we were able to find population sets that separate the population by month as well as year, because then it would just be a little more accurate for the population, because a lot of the snowbirds aren't actually residents of Florida, they're residents of other states, so they're not all taken into account when the census is done every year. Florida also experiences a 5% increase in their population from mid-October to mid-May, like I said previously. So if they're not there when the census is happening, then they're not included in it, which would affect the data.
And then some suggestions is that when the car accidents,
Car accidents are obviously inevitable and they're going to happen no matter what, but one of the steps that Florida could take to limit the severity of crashes would be to lower the speed limit. In places like New York, where I'm from, the speed limit on the highway is 55, whereas here the speed limit is 65. So if we lower the speed of crashes, I think it would lower the speed of impact, and then it would lower the severity of the crash.
It's hard to say though because in Wisconsin it's 70 and it's pretty similar to Florida, but it's kind of like city where New York is just packed and that's where it's got to be slower. Another way to help the number of accidents is providing better public transportation. Because a lot of the snowbirds are elderly, they kind of suck at driving and they have a lot of impaired vision, reaction time, and such as you get older, which causes more accidents. And then these are just our references.
Just the 2 data sets.